or you guys can watch the video. But one application of radicals is the formula S of D equals the square root of 9.8 D, where S of D is the speed in meters per second and D is the depth of water in meters. This formula is used to estimate the speed of a tsunami. A tsunami is a series of large waves generated by an abrupt movement on the ocean floor. Powerful undersea earthquakes are responsible for most tsunamis. Tsunamis occur most often in the United States and the state of Alaska. However, the small town of Crescent City, California, has been dubbed the tsunami capital of the continental United States. There you go. That's maybe a little bit more information than you wanted. So number one, it says use the formula S of D equals the square root of 9.8 D to calculate the estimated speed in meters per second of a tsunami if the disturbance occurred at an ocean depth of 4,500 meters. So let's highlight some stuff on this. Okay, we know D is the depth of the water in meters for the formula. And this one gave us a depth of 4,500 meters, right? So I can go into this formula, and yeah, we'll show it as S of D. I'll change that up. It's S of D equals the square root of 9.8 D. Now, it just told us a D value, right? It's saying that in this one that D equals 4,500. Meters if you want. But that means I'm going to go into the formula and replace the D with 4,500. So it's the speed based on 4,500 meter depth. And so it's 9.8 times 4,500. And, again, I apologize if that's kind of small, but I'm going to go to my calculator to type this in, okay? So the square root of 9.8 times 4,500, and this one comes out very clean. It gives me exactly 210. Now remember, since we have a word problem on this one, the answer is not just 210. It's 210, and it's a speed, which it showed back here is meters per second. So I'm just going to put meters per second like this. So that's the answer to that first problem right there. All right, so number two, convert the answer from question one from meters per second to kilometers per hour. And a meter per second is equal to 3.6 kilometers per hour. So this is kind of going back to 950. I think it was our sixth unit. But whether you took 950 or not doesn't matter. Let's go over on how this one works. Okay, so right now we're saying that it's traveling at 210 meters per second. And now this one says that a meter per second is the same as 3.6 kilometers per hour. So I'm going to take that 210 meters per second. I'm just going to show it as a fraction just because, at least for me, it's a little bit easier to work with this when I'm looking at it in fractions. So I know where I can cancel things out. Okay, so this meters per second is the same thing, at least one of them is the same thing as 3.6 kilometers per hour. And we want this in kilometers per hour. Oh, okay. So if I take this 210 meters per second, a meter per second is equal to 3.6 kilometers per hour. So it's 3.6 groups of this 210, or 210 groups of 3.6. So just to show the work on this, again, this would be the dimensional analysis for it. It's 3.6 kilometers per 1 hour. And again, that's the same thing as meters per second. So, well, maybe it's not the dimensional analysis. That's okay. But those are going to cancel out. And you got, really, it's just 210 times 3.6. Calculator for that one. So 210 times 3.6, which is 756. So that's that question 2 there, which is 756 kilometers per hour. Maybe I should box these in. So yeah, there was no need for dimensional analysis if we look at it as 210 groups of the 3.6. So number 3, using the answer from question 2, how long would it take for a tsunami that started in Alaska to reach Crescent City, California, which is 270 kilometers away? Okay, well this one will work with kind of with dimensional analysis. Well, it's how many 256 kilometers per hour are in 2,700. That's a division problem, you guys. So this is number 3, right? We're taking the distance, 2,700 kilometers, and if I were to divide this by 756 kilometers per hour, this will tell me how long it's going to take, because we don't divide fractions like it's showing right there. We only multiply them, right? But if I do that, I got to reciprocate the divisor right here. So that's 1 hour per 756 kilometers. And this one is kind of the dimensional analysis of it, because the 2,700 kilometers, the kilometers are going to cancel out. One in the numerator, one in the denominator. So it really ends up just being 2,700 divided by that 756, which is, it's kind of shown with the fraction, because it's fraction multiplication. So multiply the numerators, multiply the denominators. You got 2,700 divided by 756. Now I get a decimal, and it said round answer to the nearest tenth of an hour. So this is the decimal that I got, though. It's 3.5714. Okay, but it said round to the tenth, the nearest tenth. But that's the 5. So the 7 right there is going to add 1 to the 5. So it ends up being 3.6 hours. And again, that's the answer to number 3 right there. And again, don't forget to label these, all right? Because if you guys submit these on Canvas and it's not labeled, I have to take a point off. Okay? Yes? So number 4, how might knowing the answer to question 3 be beneficial to the residents of Crescent City, California? Well, we got, 3.6 hours? So it's it gives them some time to prepare for the coming tsunami, right? Or some students say it gives them time to evacuate. However you want to put it, I'm going to say prepare, because preparing could include evacuation. It gives them 3.6 hours, or approximately 3.6 hours, to prepare for the coming tsunami. There we go, man. Yeah, that would be the answer to number 4.